Hi, Valari. Valari is a outreach intern working on the Ceph project on Teuthology. So yeah, please go ahead whenever you're ready.
So, hello everyone, I am Vallari Agarwal. I am the outreach summer intern for this cohort. I was working on the project Making Pathology a Better Detective. I worked with my mentors, Zach, Junior, Ashera, and Josh. Um, so in this presentation, I will explain general overflow of pathology, the problem that I worked on, the solution that we came up with, the benefits of those solutions, a little brief explanation on the implementation of that solution, and how we can adopt that solution further for more tests and any future improvements that we can have. So to start with general overflow, pathology is a framework with which we can run vast amount of tests. So we have a package of tasks that makes up one job, and then a collection of jobs which makes a complete test run. So to schedule a test run, we push our code to Ceph CI. We push a branch to Ceph CI. Ceph CI is a clone of the Ceph original repo, which is specific to trigger the package building. So when we push to Ceph CI, Jenkins is a package builder which builds a package for that specific branch and pushes the information about the package to Sharpen. Sharpen is a database and an API which stores information about what the status of the package is, what branch it's run against, and all of the information. So now to schedule a test suite, if you have the right access to this API labs, which is a pool of labs through which we schedule our tests. So if you have access to that, you run the Teuthology suite commands with and pass some arguments to that command, which specify all the details that of that scheduling that you're doing, the priority it should have, which suit you're running, and what filters you want to have, and all of the information. So the pathology scheduler schedules job according to the configuration of the jobs. So it performs a series of tasks, the pathology scheduler. First, it queries Shaman and asks if the package is built and it's ready. If the Shaman replies, yes, it's ready, then pathology scheduler goes to the next step, which is building the entire config of how all the configurations of the jobs. After building that, it stores that information to Paddles. Paddles is a database where we save all the information related to our test run and all the jobs. So, and it stores information like the statuses of the job, if it's passing, failing. It has information about the results of the jobs, who ran that job, when exact time that they ran it. We can access information on Paddles through Pulpito, which is the front end, and what the code reviewers, test reviewers refer to. The other place that scheduler pushes this job information is the beanstalk queue. It's a queue which should keeps all the jobs in according to their priorities, an order in which that they will be executed. So the Beanstalk queue has also different queues. So we have Smithy machines, Mira machines. So every kind of machine has their own queue, and the pathology dispatcher picks up jobs from that queue, and a dispatcher is responsible for doing the entire running of the actual jobs, which is getting the machines ready by reimaging it and then actually running those jobs. When we get the results of those test run, they are pushed to Paddles, and which the reviewers can view it on Pulpito. So this is a general overview of how pathology works and all the components that it has. If you have any questions, you can ask them now or maybe at the end of the talk. So the problem that I worked on was, so we have tasks in our jobs. Those tasks could be unit tests, and when those unit tests fail, uh, our pathology throws a command failure error, which is a vague error which does not specify which unit test is failing. So, mm, so what happens is the reviewer has to go through the pathology log files, which can be really large, and look through that log file to find where each test failed, where it failed, and all of that information. So it takes quite a bit of amount of time for the reviewer. And the other thing is that the error which is captured in paddles, the results which are stored, they don't, they aren't very specific or meaningful because the description of the failure is very vague. So currently, uh, this is a screenshot of a pulpito. This is a test run, and this is our job ID. When we see a test failing, we see that there's a command failure, and we see a bunch of text which does not specify that which unit test is failing, or even in fact a unit test is failing. So, so, so in our solution, what we're doing is before when reviewers had to look through the Teuthology logs. We are automating that feature. The Teuthology can look through the errors in the Teuthology log files and throw a new kind of error, which is unit test error, instead of that vague error. So we made so if you pass can logs true, a key value error in the jobs YAML file, this will enable this feature. We have made this feature opt-in. So if some teams decide that their pathology log files are too large, so they can opt out of it because scanning logs will take a bit of time. Uh, so this enables Teuthology to scan all the errors. It searches for a specific word to find that error related to that, and prints a new kind of error, unit test error, and prints that to paddles. So now, if you look at how the error looks in our Teuthology in our Pulpito is, we see a simple error with no test fail. No test is a Python unit test library, and we see the exact error which failed, the exact function that failed, the unit test function, instead of a vague wordy command failure. So the benefits of these solutions are, with this, we save the time of the engineer to go through the pathology log files. It saves about 5 minutes of engineer's time to look through the logs per run. And it also improves the error tracking and the errors which are stored in paddles for sentry purposes. And instead of command failure, it stores the exact error which failed, the exact test which failed. Another great point is that the time difference between using this feature and not using this feature isn't great. So isn't too much the difference between the time. So our scanner takes about 1.5 seconds to scan half a GB file. So in case if you want to opt into this feature, you can opt in, but we are not forcing this feature. So if you think that your pathology logs file will be too large and you don't want to opt in for this, we are not forcing this feature. Teams can incorporate this according to their needs. So let's look at how we implemented this. If the feature is enabled, Teuthology will look for all the regexes related to that error, to that unit test error type. So if you have a nose test running, and so its failure would start with an error or a fail keyword before the error message. So that's what the Teuthology scans and finds that error message for. Then we have a flag feature where which is used to prevent that our scanner never rereads a line. So it keeps store of the last line that we read in the pathology log file and keeps checking on that and keeps a check on that, that we never read the files that we've read before. And lastly, we throw a unit test error to the battles. So while implementing this, we discussed a few ideas about how we can go about scanning our pathology log files, and uh, we use the best method we can do for scanning these large files, because we do know that they can get very large. And but of course, if you want, you can opt out of it. Now we'll go through how we can adopt this feature for other tests in future. Uh, I'll go through a brief in my presentation, then I'll give a quick demo where we can look at the code, where we have to actually add these information, look at the files, and then also you can refer to this information in the PR that Ishira can add in chat. Mm. A PR in the pathology repo. I've explained in the entire docs there as well. So there needs to be two changes that need to be made to add this feature. In the Teuthology side, and then there is Ceph QA side. In the Teuthology side, we need to add the regexes for the unit test. So there is a dictionary which maintains in key we have to add the unit test error type and a list of all the regexes that you wanted to identify related to that unit test. The other is on the Ceph QA section. We want to make sure that the orchestra run function has this new parameters, scan test errors. It is a list of all the unit tests that you want pathology to scan for. If you give a empty list, of course, you can that will opt out of this feature. Let's have a let's look at the code. So in the pathology repo, in the orchestra section directory, we have this run.py. And here we have error scanner where you can add a new unit test type and all the regexes that you want to add added related to that. So how this flows, the workflow of this is that in the QA section, this run function is called, and we want to pass a scan test error parameter, and that is all that's needed to enable it. So if you want to enable this feature on the pathology section, you just need to make um, changes here in the error pattern dictionary. Now in the Ceph QA section, for example, I'm giving an example of S3 test, which runs the nose test. So in this, when we call this run function, we want to ensure that the error test scanner has a list which has nose in it. Now to make this feature opt-in, we have this is a jobs YAML file, and if we have we have this key value pair. If we have a scan logs to true, um, here it's disabled, and if it's true, then in the HCLS PY file, we read for the scan log if it's there in the client config. The client config is this, and and if it's there, it searches for its value if that's true. And if it does, then error scanner adds nose to it, and that's passed. If it's not, then it just prints a passes a empty string, and it does not scan. So, any questions on these things? Okay, go back. PPT. course, if that went, if you have any questions, you can look through the docs in the PR. So for feature improvements, currently we have, as we just saw the code, nose test and G test enabled. So we can add coverage for more tests and add more tests to this feature, so people don't have to look through the logs. And you can also refer to both my PRs here. And that's all. Let me know if you have any questions.
Yeah, folks, feel free to share your questions in the chat, or you can speak up if you're comfortable.
I don't really have much questions, but yeah, great job overall. I think you explained it pretty well, for me at least. Yeah, great job, Valerie.
Yeah, there's no questions in the chat.
Okay.
I have
Great.
a quick question. So first of all, great job, Valerie. This looks great. How did you check for false negatives or false positives in the detection of errors?
In the detection of errors, so I did a test run and I took that file and duplicated that a couple of times manually and locally in the same file, so it becomes a huge file. And I changed the errors in each line, all the duplications, so I could see that the flag feature isn't actually rereading, and also that the first error is captured and some old error is not captured. So just to test that the error is initiated at the right place.
Right. Yeah, I think it can be really useful once the feature is enabled. That at least for some transition period, the engineers will compare the detections of the errors to see that the tool is working correctly, and have some improvements in case needed. So I'll have some like humans looking at it as well to verify that it's doing what we expect.
Right. And the more and more we use this feature, we can have more plans on what's missing and what we can add to it.
Yeah, it's just that with regex many times there are so many patterns that we can miss. So, and there are new things all the time. So it's really good that someone is looking, at the output of the tool. So that's all I'm saying.
Right. Yeah, I'll try to look through and add more regexes if that is possible and look through those scenarios.
Yeah, and great presentation. Thanks.
Yeah, to follow up on that, I think Yarid made a good point. I think the channel where users of this feature can report their analysis. Let's say if they have if it's not doing the right thing, maybe other than I think they can report it through a tracker, open a tracker and specifically say they opt into this feature, and then it's not okay, let's say it's missing some cases. So yeah, I think that could be the first channel of reporting any errors that this feature can make.
For sure.
I have no questions, Valerie, but I just wanted to say it was a great presentation. And I think this work is very valuable and it can save a bunch of time going through lots of failures and helping identifying them. And even as a stretch goal, the next step could be automatically post the run to the tracker, to the relevant tracker, if there's one exists. This also can save time. But thank you very much for your work.
Great idea. Thank you. If there are no questions, this is all from my end.
Thanks, everyone. Thank you.
Thanks, Valerie. Thanks, everyone.
Thank you.
Thanks, Valerie. And thanks, Gaurav, for hosting this. See you.
Yeah. Thank you, Gaurav.